Alright, so in this video we're going to discuss momentum. Now I'm sure most of you are familiar with the word momentum when referencing a sports team that's doing well. They're gaining the momentum or they have the momentum. But what exactly does the word momentum mean, especially in physics? Well, we define momentum as the quantity of motion an object has. Now since objects all have mass, we could then say it is mass in motion. So we define momentum using the equation momentum equals mass times velocity. If we have an object, we know it has mass. And if that object is moving with a velocity or a speed, then that mass has momentum. So since the equation is momentum equals mass times velocity, we use the variable p to replace momentum. And that will be equal to our mass, which we know is m, times our velocity, which we know is v. So this will be the equation we would use to find an object's momentum. Now looking at this equation, we can figure out exactly how the momentum changes when the mass changes. So when we have a large mass, so let's think of a large mass. I'll draw a large mass and I'll draw a small mass. If both objects move at the same velocity, we will say v, who would have the greater momentum? Well, we look at our equation. We see that momentum is predicated on the mass times velocity. So if the mass is large and we have a constant velocity, then we know that our p must be large. Whereas in example number 2, we have a small mass moving at the same velocity. We know our p must be small. So let me put a small p, since p is predicated on the mass of an object. Now that works the same way if the mass, so now let's use another example. So this was example 1. We'll just put example 1 here. Okay. And now let's look at example 2. What happens if we keep now the mass constant? So I'm going to draw now 2 circles with the same mass, except now our velocity vectors are different. So we're going to have a very large v and a very small v. What happens to our p? Well, looking at the formula, since v is directly proportional to p, if v is large, then our momentum is very large. And if v is very small, then our momentum is very small. And that makes sense if you think about it. You can reference it back to sports. If a team is doing very, very well, winning a lot of games, they have momentum. They have a very big momentum. But if they're winning sporadically, maybe losing, winning, losing, winning, they're not really moving very fast. They would have a small momentum. They don't have momentum. So if you can't really conceptualize this in let's say the physics mentality, you could always reference sports and understand how momentum works, especially with the winning and losing. Alright, so let's do a couple of example problems to see if we understand the concept of momentum. So one says, determine the momentum of a 60 kilogram halfback moving eastward at 9 meters per second. So let's draw the figure to see exactly what we're talking about. Alright, we have an object, and that object is moving with a velocity of 9 meters per second, and the object's mass is 60 kilograms. So we could say that this is 60 kg. Okay? So what's the momentum? Well, we said that P equals mass times velocity. Therefore, the mass is 60 kilograms times our velocity, which is 9 meters per second. Therefore, our momentum equals 540. And what are the units for momentum? Well, we have a kilogram, we have a meter, so it would be kilogram meter divided by the second. And what direction does our momentum go in? Well, our momentum goes in the same direction as our velocity. So our velocity here is going eastward. I'll underline it. Therefore, our momentum is going eastward. Remember, momentum is a vector quantity. Alright, we could try the next one. Put in a different color. A 1,000 kilogram car moving northward at 20 meters per second. Again, let's draw our figure. This is 1,000 kilos. So it's a big object. 1,000 kilos. And this object is moving northward at 20 meters per second. So, northward, we'll draw our vector like this. And we'll say 20 meters per second. Alright, again, our equation is P equals M times V. We substitute the information in. We have a 1,000 kilogram object. How fast is it going? It's going 20 meters per second. Okay, now, should our momentum be larger or smaller than the previous example? Well, our mass is increased and our speed is increased. So this P should be a very large P. And we find out that our answer is 20,000. Again, what's our units? The kilogram meter per second. And which direction are we going in? The same direction as our velocity, which is northward. Okay. The third question is the same as the first two, so what I'll do is I'll just put the answer. If you want to try it out for yourself, you can. The third question's solution is P equals 80 kilogram meter per second, and it's going southward. Alright, let's try the bottom problem. Number 2 says, a car possesses a 20,000 units of momentum. What would be the car's new momentum if its velocity was doubled? So let's think about this. If P equals M times V, alright, and we know that our P is 20,000 units, 20,000, and we double the velocity. So let's double the velocity. We have the M, and I'll write in a different color, 2 times the V. We doubled the V. What do we have to do to the other side? Well, the other side, since we doubled the V, has to double the P. So let's put 2 on the other side. So we get 2 times now 20,000. Oh, 20,000. Let me rewrite that. 20,000, which equals M times 2V, like so. So what does P equal? We see that P has to equal then 40,000. Okay, do we see how we got that? We double the velocity means we have to double the momentum because they are directly proportional. Alright, so B and C is pretty much the same thing. So what I'll do is I'll just write in the answers. So for B, the answer would be 60,000 units. So P equals 60,000 units. And for C, P equals 40,000 units. Again, both the velocity and the mass are directly proportional to the momentum. So if we increase the mass and increase the velocity, the momentum will increase accordingly. And if we decrease the mass or decrease the velocity, then it'll decrease the momentum. I would like to do D, because D I think is a good problem. If we double the velocity and double the mass, what happens? Okay, well, let's write out the equation first. P equals m times v. And we know that P equals 20,000 units, so we'll put 20,000 units in the left. And what is happening to the right-hand side of the equation? Well, we want to double the velocity, so I'll double the velocity, and we want to double the mass. So double the mass, and that will be multiplied by doubling the velocity. So what do we do on the right-hand side of the equation? The entire right-hand side of the equation was increased by a factor of 4. It was multiplied by a factor of 4. So I'll rewrite the equation as 20,000 equals 4 times mv. Now, since the equation was changed by a factor of 4 on the right side, we have to now change it by a factor of 4 on the left side. So we get 4 times 20,000 equals 4 times mv. Now our equation is equal, so our new P has to equal, P therefore equals 4 times 20,000, which is 80,000 units. Alright, so now we'll learn about impulse. Now we define impulse as the product of the net force acting on an object and the time during which the force acts. So we can write the equation of impulse as J equals force net, which we have learned, times the time in which that force is occurring. And that equals our J, which is our impulse. Now we'll get a little bit more into impulse on Wednesday, but for tomorrow, all I need you to understand is that the impulse's direction is the same as the force direction. So I'll write that star. Direction of impulse, I should say of the impulse, is the same as the force net. Alright, and other than that, all you need to know is that J, the units of J equals the Newton, because we're dealing with force, and the second, because we're dealing with time. So it's the Newton second is the units. Other than that, we'll get more into the change in momentum and the conservation of momentum on Wednesday. So now you can answer all the questions that are due for today.